A very good evening to one and all gathered here. On behalf of the Department of Computer Science, Christ deemed to be University, Bangalore Central Campus, we welcome you all for the 7 days online FDP on software engineering, the practical approaches, as well as the technical perspectives, and with tools and techniques as well. As a formal part of this program, let us start this event with a silent prayer, looking towards the grace of God, His blessing, and His marvelous guidance throughout this 7 days online FDP. We'll start this FDP with a silent prayer. Thank you. Now, here we are starting this event with an inaugural address by our beloved head of the department, Dr. Ashok Emmanuel, who is vibrant, who have been the person behind this FDP, guiding us throughout the journey. Over to Dr. Ashok Emmanuel.
Thank you, Sarthak, and thank you all for joining this evening. It's just a pleasure for us to meet you all online, though we are not able to see you all, but we believe that you're going to be benefited with the 7 days program. Sometime back, there was some guests for us for one of our event, and a person from ISRO had come, and he was narrating the course of actions which are happening during the Chandrayaan 2 and 3, and a lot of other technical details he was briefing to students and to us. Very interesting. To our dismay, it was a software glitch at the last stage. So what we understood is no matter whatever we do today, everything can be attributed to software. You see anywhere and everywhere, software is a very, very important aspect. I realized that I don't know whether there's any other knack of an eye can wipe out billions of dollars, but software can do. One small bug in a software can change anything to simply zero, right? Just in a blink of eye, completed billions of dollars can be lost. So such is the power of software in today's world and today's context. So it is very important to understand how the software is prepared and what kind of engineering process has to be taken up for making sure that no such calamity happens in the software world. So much so that though we teach a lot of software engineering principles in the academic world, still it is very important to understand what exactly happens in the ground reality, what happens in the industry. So that is the entire idea of this FTP, trying to understand how much of software engineering process is very, very vital in preparing the softwares, and what kind of intricacies, what kind of troubles, and what kind of efforts is taken to ensure that we have a safer world as far as softwares are concerned. At this note, I would like to congratulate Sahaya ma'am, Dr. Sahaya, for putting up this work together. She has been almost 2 or 3 months, she has been working very hard, putting up all the speakers. She has got an array of speakers from different corners of the world talking to us on software engineering principle. And I'm hoping that it will be a very, very beneficial time what you spend in terms of gaining knowledge. So with that note, I would like to thank and wish you all the best. Thank you very much.
Thank you, Dr. Ashok Emmanuel, for that vibrant and motivating inaugural address. Now, Christ University is not well known for the academics, but we always focus on extracurricular and co-curricular events as well. The Department of Computer Science is hosting a very famous and a vibrant event of Interface 2024. Here comes Dr. Sangeeta to introduce about the event.
Yeah, thank you, Sagaya ma'am. Good evening, one and all. I first of all congratulate all the participants for joining the international conference, and I'm so happy and glad to introduce our Interface Fest. So the Department of Computer Science at Christ deemed to be university is calling out all the tech enthusiasts, innovators and visionaries to Interface 2024, which is our national level computer fest. It is just not an event. It is an experience, I can say, with 3 mind-blending technical fest and 2 captivating non-technical fest. We are bringing you a celebration of technology like never before. So I would request the technical team to play the promo. Thank you for that. So I would request all the participants to share it with your students who can sharpen their coding skills, ignite their creativity, and gear up for the intense competitions that will push limits. But that's not all. They can unleash the competitive spirit in the gaming tournaments, dive into cutting edge workshops, and connect with the like minded individuals from around the nation. So interface is just not about bytes and code. It's about forging lasting connections and having a blast while doing it. So take a next step by sharing with our students, which will be, the link will be shared in our chat, maybe by the end of the session. And thank you, Sagaya ma'am, for giving me this opportunity to talk about interface. Thank you, and my best wishes to one and all. Thank you.
Thank you, Dr. Sangeeta, for that wonderful invitation on behalf of Department of Computer Science. Here we are going to our session of the day. I'm very pleased to introduce Mr. Sarthak, who's our resource person for the day. He is serving as a product analyst, and he works as a central divider for the development and adoption of data-driven decision-making, data governance, analytics, and experimentation guidelines and infrastructure for a product center around self-learning in the educational technology space. He sets up process around experimentation and collaborative decision making while ensuring that every major and minor decision could be tracked and that the product roadmap was always structured around KPIs and key objectives. He also identifies and implements critical improvements and blind spots for which data could be collected and used for effective decision making. He works on both mobile and desktop products, catering in multiple languages and geographical regions across the globe. We are very happy to share with you that he has a BCA degree in computer science from our very own Christ University Department of Computer Science and postgraduate diploma in computer science. He has gained broad exposure to data analysis and ML algorithm, automation for B2B SaaS applications in fintech and e-commerce industries. He has also worked in programmatic advertising space, developing the product roadmap for code on page, ads serving products, and guiding business engineering, product operation teams with publishers on board, and managing supply side integrations. He has worked with huge data set on Hadoop's cluster, interface through Hive, and drawn insights for product development, health, and competitive opportunity monetization. He has also implemented XGBoost classifiers and K-modes clustering and created, maintained dashboards, data pre-processing, and external stakeholders reporting. His goal is to make every decision data-driven and scientific, and to conceptualize, guide, and develop the ML-based and data-driven products using scientific approaches such as user research, market analysis, A/B test, UI optimization, and KPIs. He also enjoys spending time guiding people in achieving their career goals through resume review, technical training plans, interview preparation, mock interviews, and much more. Sarthak, we are very happy to have you in midst of us. Over to you.
Thanks a lot, ma'am. It was a very detailed introduction, I must say. Okay, so let's maybe dive into the session for the day. Before this, I would like to thank everybody from Christ University who's made this possible. Firstly, Dr. Father Joe CC and Dr. Ashok Emmanuel, our Honorable HOD, and then also the coordinators for the program, that is Dr. Asage Aurelia and Dr. Smita Vinod. Now, moving forward, I'll just stop the slideshow. So, our topic for the day is simply diving deep into how decisions are made currently at companies. There's been a very radical shift at companies these days. That is 50 years ago, since 50 years ago, that is 50 years ago, companies used to be way more field driven. That is, I see that the user has a pain point. I see that the user needs something, and I build a product for this. However, now companies are going into more uh, a, a broader infrastructure because every company is thinking of scaling up. When we build products for pain points, we forget that at some point of time we are going to start having to earn revenue out of this product. We are going to start having to scale this product to multiple more markets. We are going to have to build a product which is going to be fitted into various different cultures across like across India or across the world. And now companies are taking decisions based on data. Data allows us to aggregate results, to aggregate all of these miniature pain points into a broader picture. It allows us to see statistically whether our product would work or not work when we start figuring out how to scale this product. And so scaling and growth is where data comes into play. Now, I will dive a little bit deeper into how companies can do this. Growth can work in two ways. The first, and the traditional way of doing growth, was sales-led growth. Sales-led growth meant that companies strive towards one and only one thing, that is revenue at the end of the day, and everything else takes a backseat. If revenue is coming in, if my product is being bought, that's all I care about. I don't care about how the product is being used. I do care about it, but I don't look into it for growth. I don't care about whether I could scale my product further to allow venturing into a new market. But whatever product I have, this is gonna be what's gonna be sold for now, as long as sales itself dives, and then I say, hey, like now we are no longer able to sell this product. Can you please make these 10 features which people are asking us during sales interviews? And then like the development team builds these features, then we release a new product, and similarly the new cycle of going towards revenue continues. Whereas product-led growth, on the other hand, is a technique in which instead of working through just sales, even though sales-led growth still exists, that is, sales teams do guide what to build next, there is also a product-based user research. Product teams are very different than they were 10 years ago. Earlier, there was only an engineering manager, and everything comes from the management or sales about what to build next. However, now product teams have a product manager, a product analyst, and the job of a product manager these days is to make a roadmap in such a way that that this roadmap is research driven itself. How do you identify something that is research driven when you haven't even released a product, when you haven't even checked whether the product works with the user base you're trying to target? The only two ways to do that is either through data or through surveys and interviews, right? So either classical research or through a data-driven decision making. And that's a point for the day: data-driven decision making. Product-led companies heavily work with data. As you see, the flow when sales-led growth versus product-led growth, In sales-led growth, you would go with a demo, a sales conversation, a contract configuration, training, and then finally the customer starts using the product. Whereas in product-led growth, you start with discovery. Discovery in itself is a very in-depth form of data-driven decision making. I would say not only data-driven decision making, but also market-driven decision making. So the discovery phase involves, let's say, market research. It would involve, of course, interviews and sales, like interviews and cold calls and such to figure out whether there is reception for the product in the market. Then you would go towards a free trial or a demo of some sorts wherein the customer uses the product at this point. So you see the difference in sales-led growth. Only after the whole onboarding is done, only after the user starts paying us, do we go with do we let the user use the product. Before that, there's just a demo which is given by somebody within the organization to the customer. Whereas in product-led growth, we heavily depend on how the customer is going to use our product. That is why we let the customer use our product freely in the beginning to get more indicators from this free trial as to how we can develop further. And this free trial gives us lots of data, gives us lots of discovery, and this free trial enables us to develop more streams of user research. That is, if somebody's already used our product, we can go back to the principles from sales-led growth and talk to them and see what they're missing. That makes a knowledge base, which and it also makes a community for us. It also makes users who are interested in using our products and users who will potentially be interested in using our product if we make certain developments right in the beginning. So the biggest opportunity in product-led growth, I would say, is small capital to start, right? In sales-led growth, you need a complete product to work with before you can even start letting users use it, because the user pays for it. Whereas in product-led growth, you can always start with an MVP, a minimum viable product, which then users use, give you more knowledge based on their usage, based on your usage, they generate data for the product, and this in turn helps us then basically we know much more by investing way lesser capital, and then we persuade purchase towards the end. And this is also all done through this is all the persuasion of purchase also usually happens through technical means and not the sales team itself. A classic example of this is something that I can show you here. Would be a website which almost everybody knows, Khan Academy. Khan Academy does not have a sales team, but Khan Academy is still one of the most popular e-learning products available all across the globe. It is offered in 190 countries, and it is built by an NGO and works on only community funding. Why would somebody want to pay for this product? They want to pay for this product because they got to use this product, and then Khan Academy was able to get more insights into how people use their product, and they started with just math. And right now they offer test preparation, computer sciences, arts and humanities, economics, and many other things on their platform. But they're completely community run. Again, without a sales team, the only reason why they were able to do this is because they had a product, a minimum viable product, that is math courses. They served it to people. They got input on how they can improve it, and then they went forward into building the product into what it is today. If you've used Khan Academy at some point in the past, you must remember that a few years ago, their UI used to be very different. It used to be really a very basic HTML4 website, which was essentially like not even being being maintained very much. But as people started using their product, as they started seeing value in the product, they started donating to the company and donating to the NGO, and this enabled them to build a better website to cater to their users' needs more. And right now, it's the topmost free product available for learning across the globe. Going forward, how is data analytics changing, or how is data-driven decision-making changing? As we spoke about older kind of companies, sales-led growth and revenue being the topmost goal. Earlier, companies used to optimize only for revenue, optimize only for numbers which only grow, right? Now, data analytics focuses more on unit economics, talking about how much money do I earn per customer. And then as I gain customers, as I scale up, my money would multiply. To get to unit economics, you of course need to build some infrastructure. You need to ensure that you have analytics systems in place. You need to have your research systems in place. You need to be able to experiment, and you need to be able to build solutions which help you get to the point where with a limited amount of capital in both time and money, you can build something which gives the users uh, most of the benefit that they're looking for within the product. Uh, Let's start with the first part already, infrastructure. I'm pretty sure all of you have heard about databases, right? Databases are not what they used to be in the past, especially in analytics databases. Earlier, there used to be relational databases. Like, of course, relational databases still exist, but they exist in the software engineering space, no longer in the data analytics space. In the data analytics space, the relational database just exists as a source of truth. If the data in my analytics engine is wrong, then I go look at data in the relational database and see what's going wrong. However, relational databases are completely out of the picture right now for data analytics, because right now we use event-driven databases. We are more interested in how users are behaving on the product. Earlier, we were only interested in what are the key points in my product where I need to collect data. I'll give you an example of this. So earlier, for example, let's just go to something like Amazon. This is like a very classic example. Earlier, if Amazon was operating 50 years ago, or like even like 20 years ago, what they would be looking at mostly would be, hey, okay, which kind, like they're interested in certain key features, right, of the website. They're interested in certain key goals. The goal for an e-commerce company, what could it be? Of course, selling products. Now, at the beginning, like 20 years, 30 years ago, Amazon would be majorly looking at how many products are being sold, what kind of products are being sold, which kind of categories are working, which kind of categories are not working, and such. But now I am also interested in how these products are being sold, what kind of behaviors lead to the product being sold. So I would now want to look at stuff like, do people click on the fresh link here to start, like for example, if they which kind of links on the website are being clicked more, whether the users, before actually buying products in their shopping basket, like clicking on the buy button, do they go actually do they go actually to different links? How do they work with different links available on the website? Which kind of products do they see before they actually convert to a purchase? And this is being done through event-driven infrastructure. One example of event-driven infrastructure would be that websites these days, for example, even social media, track each and every click you make on the website, each and every scroll you do on the website, all the likes, all the comments, and everything. And they track at which times they happen as well. So not only the actions. Earlier, we were tracking only actions. That is, a user has purchased a product. Now we are more interested in what has the user done to purchase a product. these databases are way more complex because I need to like track each and everything. I need to track whether this menu was opened. I need to track whether they went to. So this website is Study Smarter. It's another e-learning website where free content is available. And luckily, I was able to access their event infrastructure using an add-on because they're using a product called Amplitude. So I'm just showing you how they have programmed their event infrastructure. Whenever you open the website, this this like in this basically triggers an event called page view, and this page view event contains some information about the page and such within the event. Similarly, if you go to another page, that is like, let's say if you want to work with chemistry, it triggers another page view, and I get to see that the user opened chemistry, whether what kind of data they're looking at. It's an explanation on the main topic. Um, they're collecting information on which subject it is. They're collecting information on whether there's a test quiz at the bottom or not. Like, so uh, some of their topics must have test quizzes at the bottom. They're talking about they're tracking my scrolls. So as I scroll down the page, I see a page scroll event, right? So from relational databases, which were mostly point in time, that is, I see what is late, like the latest thing that has happened, right? So for example, a row in a relational database which says which is in a table called cart, right? It would show whether this cart was is currently active, or the cart has already been bought. But if I look at a database like which is an event-driven database, which is what we see here on the right side, you can get much more information. For example, at which points of time were each of the products in the Cart added? What did users do before before adding their products to the cart? Which kind of products were viewed before adding to the cart? Similarly, you see here at the top of every page, they're asking us to sign up for free. At the top of the page, on every page, they're asking us to open the app. So what they want to do is ensure that people sign up or people open the app. And using these event-driven databases, I can essentially get data on what happened, which led to the person clicking here to sign up for free. And these behaviors I would analyze and then work with it, which we will discuss in a bit. But like but what I wanted to highlight here is that now we track each and every user action on each website, and this has some associated data with it to give us breakdowns and to give us time information on when these events happened, right? Also, you can imagine that when you have such data for millions of users, you can always look at what kind of like how many users actually converted to a purchase, how many users did not convert to a purchase, or rather in the terms of Study Smarter, they could be talking about how many users actually signed up, how many users didn't sign up, how many users after signing up used the application, and how many didn't, and these kind of things. Coming back to our analytics techniques now. So this was all about databases. There is a lot more happening on the data engineering front, actually. But this would be a topic for another day because right now we are discussing analytics, and let's dive into analytics, which is the main topic for the day, and taking decisions through analytics. First, this event-driven databases, these event-driven structures have enabled us to increase the strength of exploration that we do. We are not like earlier, as you saw in our so this is a form of classical analysis. It's called the RFM analysis: recency, frequency, and monetary value. It says that a user has if you want to see how much value a user has for you, you want to see how recently a user did a high value action at your platform. With what frequency did the user do this high value action? That is, how many times the user did this high value action in a given time period, and what kind of monetary value this user generated for you. That would be their lifetime value, LTV, and such. Earlier, we usually only used to look at the monetary value. However, now you can look at many other things except monetary value. So now monetary values definition itself has changed. The strength of exploration has increased in terms of that we don't only measure success in dollars. We measure success in various other factors. We measure success also by seeing how many users are actually active on our product, for example, in a given week or a given month, and how this increases over time. We measure value like in like you must have seen on several websites. They mention our user base has grown by 20% in the last year. Why do they mention this? They mention this because if users see that since last year to now, this company has grown their customer base by 20%, there must be something that they're doing right. So this doesn't only give us power to persuade our consumers more, but it also gives us the power to take better decisions. It also gives us the power to plan um, milestones or high value actions which lead up to the dollars or euros in this case, pounds in this case. But yeah, so the definition of monetary value has changed. It could be now engagement with the product. It could be it could be whether they do a certain action on the product, whether they reach a certain milestone in the product, whether they complete a certain procedure on the product, and could be many other things. Let's try to do this. Let's try to put this into perspective with an example as well. So let's come back to Study Smarter. Now we don't need the event infrastructure already. Uh, so Study Smarter's main goal on this website, as we see very clearly, is to make people sign up. It says get started here for free. It says that it has a register option on the top. As you scroll down, it says get started for free again. Then it tells you a little bit more information, says get started for free again, and then again, and then again at the end. So they want users to start using their app. Now, how do they do this? They have this website and they want users to get to their app. But showing users just these like marketing collaterals might not be enough. Just showing users what features the app has might not be enough. So what they did was they added a lot of free content. They added biology, chemistry, math, all kinds of content on the website for school, for training, like training as in like in it's something like an ITI for Germany, um, like basically vocational training. So they started adding a lot of content here for free. So people start learning the content. People start seeing that the quality of this content is really nice. People start searching for this content on Google, and then these pages which have the content turn up there, and they come to Study Smarter's website. And as you view this content, as you learn about this content, they start asking you to sign up again and tell you, hey, there is much more available on the app. So currently it is now shifting heavily towards making users do high value actions. For Study Smarter, the high value action for their website is to get users onto the app. Maybe because on the app itself, they start monetizing stuff. They start asking for premium features. They start asking you to use premium features and such on the app, right? So it has having an event-driven infrastructure has allowed us to do such kind of research. What could allow my users to convert to high-value actions? Building up on this a little bit, it allows us to mark user journeys. On the right side, you'd see a very simple chart based on user journeys. If you know what actions happen in a sequence. So this is, for example, the user reaches the home page, the user searches for something and reaches the search list, and then the user reaches the detail page. That is the when you click on a search when you click on a search result, you reach at a place where you have like on for example Amazon, you have the details of the product and such, right? You get to build all of this using event-based data. How would you do this using relational data? Because relational data like sure, it can be really it can really be done on relational databases as well, but essentially you'd be slowing down your website. Essentially, every the controller modules or the view modules which actually get data and post data onto the database, they would be overloaded. So instead, we manage all of this event infrastructure as third party, and or like not even third party, but rather it could also be internal, but this is always separate from the relational database which the application runs on, because you don't want to slow down the application. Um, and so usually people use third-party products for these event infrastructures like Amplitude, Clipfolio. You have Metabase, you have got Mode. These are some market leaders. There's also like for product and for marketing analytics, there's something called Mixpanel. And I think if any one of our participants has worked in the marketing space, you'd be familiar with Mixpanel and Google Analytics and such. These are market leading products for developing event infrastructures. So essentially, what we do is we just add an extra layer of JavaScript on the page, and this JavaScript as like would be executed as soon as you take an on-click action, or as soon as you take a drop-down action, or as soon as you take a scroll action. So on these on-click or on-action events, you would also program a JavaScript which sends data to another database. Connecting this a little bit to the curriculum of computer science across universities in India, you'd have noticed that this kind of an infrastructure is eerily similar to logging infrastructures like Kafka or Datadog and such, which log essentially how APIs are working. So this infrastructure of this event-based infrastructure is not new at all, but the way in this but the way it is used right now is completely new, because now we're using it to track user actions. And earlier, this infrastructure was mostly used for debugging. It was mostly used for checking whether our API is working or not, or whether when the API is having failures, in which scenarios the API has failures. So until leading up to the response of an API, until then, what are the things that the API has to do? What are the things that the request needs to contain? And all of these are logged. And then we're able to find out where the problem is with the API, for example. Or it is very useful in debugging client server architectures. However, now we have also started using this for behavioral analytics. So this whole segment of data analytics, which is dealing with user behavior and user research, is called behavioral analytics. So coming back to some other techniques that we use. So this is essentially called a funnel, checking what kind of user journey the user takes and how I can improve it. Now, here you see, maybe for my funnel, what's my end goal? The end goal is for users to reach the detail page, or for the end goal is for users to see the actual information on the website. Let's take this up in terms of another example. This is the Google merchandise page, right? So this page is for Google employees and everybody around the world to get Google products, Google branded products, YouTube branded products for their fashion, or like for office and whatnot. So if I'm started to search for something here, right? So I search for YouTube water bottle. I come here to this page. I don't see a YouTube water bottle, so I drop away, right? But how do I get this information in terms of data? I start first of all looking at this top level funnel. I start seeing that, hey, these people from the list page who did not convert to the detail page, roughly 20,000 users are dropping off. Then I want to see what exactly is making them drop off. If they're not coming from the search results page onto the item detail page, there must be something wrong with the search results. I start thinking about this. This is a hypothesis. So everything is based on hypotheses. When you look at data, you'd make a hypothesis about why a certain data looks like it looks. As I showed you in an example right now, I don't see the YouTube water bottle for me. So the search results were not relevant to me, is a major reason for people dropping off here, for example, right? Another thing. Now let's look at, for example, giving another example of how to read this data. I'm looking at users who come from the home page onto the search page. I see that only 79% of the users reach the search page, and 20% of the users roughly drop off. 20% of the users are not interested in going to the search page. Why could that be? So we already, like, I mean, a hypothesis that I bring up, I try to use the product as a product analyst. I see here the search is happening, and I try, like, and I see that, hey, whenever I click on search, this essentially opens another window here, and 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 this sort of increases the mental load on the user. This is still just a hypothesis. This might not be the reality, right? Because it increases the mental load on the user here. That is by opening another pop-up window. I could have simply just expanded search there on the top, or I could have just simply had a search box there all the time. Second, I start typing something and I press the enter key. The enter key does not work. So I have to essentially click on this go button and take the effort to click on the go button to actually reach the search page, to actually reach the search results page, right? I mark this, and this is the power of this data. I can see where people are dropping off, between which steps people drop off in my user journey, and I can optimize for it. So I say there are two problems. One, why do we have a pop-up for search? And second, why does the user need to explicitly use their mouse and press a button there when the same job could be done by the enter key? So this is how we read this data. But there are various other ways to use this data. Some of them are very scientific in nature and very theoretical in nature. So I'm going to go over them, but not in too much detail. A Bayesian analysis. So you could also do probabilistic analysis with this data, because you have sequences of events, you have sequences of actions, right? When you've got sequences of actions, you can essentially say when action A happened, that is the user went to the search screen or the search result screen, what is the probability of this user getting to the detail screen? You already know this, because if 79,100 users reached on the search screen and 52,155 users reached on the detail screen, this 52,155 is the probability of success. 52,155 divided by 79,100 gives you the probability of the user reaching the detail screen. This is a very simple analysis, right? Now, how do we do this for a very huge product where there are hundreds of actions a user can take on the page? On the right side is one possible way of doing this. That is a Markov chain. A Markov chain is a Bayesian analytics technique which allows you to mark sort of like mark the probabilities of doing an action when there could be long chains of actions and a lot of choices for performing those actions. It essentially helps you build a tree to figure out which actions are valuable for you and which actions are not. How do you see this? Here, for example, here on the right side, you see two actions that the user can take, viewing and browsing, right? For me, what if viewing is a very important action, but browsing is not an important action at all? Even though this wording doesn't really make sense, of course, but let's think of some other product. Let's think of uh, Study Smarter again. Let's come back to Study Smarter, and let's check this. So there are few things the user can do here. The user can either sign up here, the user can go to learning content and learn, the user can read about the app, the user can go to the blog, and the user can click on make a career and try to find a job here, right? There are 5 actions. What's my most important action? It is for the user to come to my app, for the user to register, for the user to sign in, and stuff like that. So if I want this action to work, using this Markov chain, I can easily identify what are the steps which lead up to the action that I want the user to perform, right? I can see what are the initial actions that the user takes usually and gets to this. So for example, I see in the journey that if the user comes to a learning content page, the probability for signing up is higher. Whereas if the user goes to the blog page, the probability of signing up is lower. What do? I ensure that I make the learning content much more prominent on my website and the blog content much less prominent. For example, by changing the blog content to the right, by shifting the blog to the right of the top navigation, or by shifting the learning content to the left, or by giving some form of like markers on the main page about the learning content that we have, or by doing various other things. I could make learning content more prominent because I see learning content makes users convert more to register on the website. So essentially, this is the power of the event-driven infrastructure that we get. Then there could be various other things you could do. You could correlate actions. Of course, correlations are very similar to Bayesian analytics, like figuring out what kind of actions lead up to something. But uh, correlations can also exist when actions are performed after a certain action. Like, for example, retention. Retention is a metric in data science which allows me to see what is the probability of the user coming back on a certain day after using my product on today, for example. So if in simple words, I'm trying to plan, I'm trying to see, okay, if customer A uses my app today, what is the probability that the customer A comes back on day 2, that is tomorrow, or the day after, or the day after that, or the week after, or the month after? That is retention, right? So here in this correlation analysis that I've posted on the right side, just a small note. All of these images are public images from different websites, the links and references of which are towards the end. So this graph, it essentially talks about the percentage of people who retained, right? Depending on the minimum times that they visited the homepage, right? So homepage visit is an action that I'm tracking, and I'm checking the count of this action and how this correlates to retention here. So these high value analyses like correlations, Bayesian analytics, and funnels or Markov chains, or just mapping user behavior in general. This is the power of data event-driven databases. They also allow us to do much more with our data. They also allow us to alter user behavior, right? Because when I see that more homepage visits mean more action to retain, right? Or for example, for Study Smarter, they see that instead of visiting the homepage, if the user visits a learning page, right? Then that just gives me the power and the knowledge to ensure that users come to this page, right? How could I do that? I could do that by ensuring that these pages have correct SEO, so search engine optimization. So these pages have enough keywords that like Google really ranks them high, right? Let's try this. I'm gonna search for applied disciplines of psychology, and let's see if Study Smarter pops up. So I start looking at class 5 Germany applied this. Okay, class 5 probably does not have psychology. Sorry. And I start looking at search results, but I don't see Study Smarter. So now I have two pieces of information. That is, Study Smarter does not show up in certain disciplines or certain keywords, and that converting to the application is much easier from the details, like from the course content pages, right? So what I do is I improve SEO on these pages, and then I check this data again to see whether I have improved in this respect or not, right? Now, I will move on to the next piece of content. And of course, if you'd like to discuss this further, you can always post questions on YouTube, and we'll take these up towards the end in some time. But moving on further, this also enables me to do better user research, or rather, user research itself is now a part of analytics. Earlier, user research used to be very classical in nature. That is, you sent surveys through letters and emails, you expect the users to reply to those surveys, or you give each user $5 or $10, and this user would come to your office and be a part of a focus group where you interview the users about your product, and see whether they can help you improve your product by giving you feedback. Now UX research or user experience research has a much wider scope. Data plays an important role. See this on this image on the right side. This is Guardian, the website Guardian, um, which is a news website essentially, and this is their homepage. There's a company which had done an analysis on where users click on the Guardian website, right? So you see these hot zones. These are where users are clicking. Here's where users click. Um, you see on the images, one interesting insight we have is that users are clicking on the faces of people more. Whereas you see this little uh, thing on the right side, the pumpkin, people hardly click here. People hardly click on multiple people on images as well. But with a single face, they're clicking heavily on that area. What insights does this give me? As Guardian, I would say, hey, maybe I should start having the faces of people as the headline image on many of my articles. I also see something else which is interesting. People are clicking on places where where there are no links on the website. For example, here, there, on the top, in the corner, like not on the like register part, but below the register part. They're clicking like on places where there is no link. Like this find a date has no link there, and people are clicking there. If people are clicking there, how do I help solve this? How do I ensure that the clicks happen at a place where they need to happen, right? This can be done through just like ensuring that my links are well highlighted, that I very clearly highlight a link when the mouse pointer goes there, or I highlight a link by having a small icon with like a screen and an arrow next to it saying that this is a link, right? And this essentially solves this problem as well. And then, of course, everything that I need users to click would be on the top left, because I see another insight here, that is users click on the top left first. That is the general flow of how our brains work. Unless you read languages which are written right to left, like Arabic. Because of learning languages, our the flow of our brain essentially is that when we look at anything which is a report, a website, or any printed piece of paper, we start reading from the top left, or start looking at the top left. So the top left also has the most amount of clicks. So any headline which I want people to go to would be on the top left here. So these are the kind of highly important results you can get from like these heat map analyses for UX research. Now you no longer need to seat people in a room and show them like a picture of your homepage showing, hey, do you think this headline on the left side makes sense, or do you think that this link on the right side is clearly visible as a link? Instead, we can already get this information from data. Another example, quickly going through this example because we're a little short on time. is the Khan Academy's old old page for donations and for getting people to contribute to Khan Academy, right? I you see this is also a heat map. Sorry for the image at the background is like a little dark, but this is how the tool generates such data. This is also data from another tool across the website. So they did this research for Khan Academy, and yeah, the tool is called Crazy Egg. If you'd like to go and look at it, they have this really cool article about this use case of Khan Academy using Crazy Eggs heat map data, right? So you see, there, like on this page, do you see the hot areas? That is the volunteer outreach area, the donate area. Do you see the Facebook areas has Facebook area has like a very good outreach, but I don't see many people going on Twitter. I don't see many people liking us on Facebook, right? So I would recommend Khan Academy to either move this find us on Facebook a little above if that is more important for them. If, for example, volunteer outreach is less important than donations, then move donations to the left, for example. And uh, I also see a lot of clicks which are happening on places which the clicks should not really happen at. For example, where does my money go? Right. This essentially is not really a drop down. This is not a link. But why are clicks happening there? Because this is underlined, right? So if I don't want people to click here, I don't mention it as a link, and I try to make it look more like text. There are other examples of such UX research. That is, something is called scroll analytics, scroll heat maps. Scroll heat maps show you where do users, till where do users scroll your website, right? This could give you various insights. It could give you insights on how much content should be on the website in one go. That is, how long of content to paste on the website, how many words to have on the website, and such. It could give you examples on. It could give you information on till where should I place any content that is important to me, till where should I place my register button, till where should I place my donate button, where should I play like till where should my essential reporting things should be. For example, if I'm publishing an executive summary, till where should the till where should the key points of the summary be. For example, I'm publishing a research paper. I need to ensure that users at least read my abstract. So if they read my abstract, at least they might have it somewhere in the back of the brain that, hey, I read a research paper which was working on this. And when they're writing a research paper, or if they write a research paper in the future, they might just cite my paper, right? So these kind of things are really important whenever doing any web analytics. Then coming on to something really important nowadays is experimentation. Experimentation is a thing that came up only because of this kind of data infrastructure where all of the user actions could be tracked, right? Um, I could show you a few. I could give you a rundown of experimentation. Earlier, experimentation still used to occur, but it was very different. Experimentation earlier was called phased releases. A phased releases essentially mean that we release the product to a few of the customers first, and then we scale it to a few more customers, then 50% of my customer base, and then I offer the product to everybody to see whether the product has some critical faults, to see whether the product has some problems. But now that the companies are not sales driven, how do I do this? I can still do this, but I wouldn't get any insight out of it because there's nobody talking to the customer over and over and asking them, hey, you had this new product, we gave it to just you and a few other customers. How is it going? Do you have any things we can improve? Because I don't want the sales team to do this, and sales hours are really important. Um, we do this through data as well now. Experimentation through data is a very big field, and people take degrees just related to this field. For an example of experimentation, for example, I come back to my Google merchandise store. and I say, hey, my analysis tells me that this pop-up is not really working well. And instead of the go button click, we should have like an enter key, or like something which is easier for the users to get to the search results page. Or even as the user starts typing in the search query, it should immediately land me on the screen of search results. Like you start typing and it immediately starts showing results, right? Um, but the product manager says, hey, but how do I know this will really improve this graph that you showed me earlier, this funnel graph? How do I know that users will really grow from the search results page to the details page more often than that? The answer to this is a very mathematical concept, which a lot of you must have heard definitely, because it's a faculty development program. So a lot of you must be in research as well, right? Um, so in research, you must have heard about statistical significance, right? Statistical significance means that if a statistical variable is changing, right? If something is increasing or decreasing, how surely can I say that this increase or decrease will work for my whole population when it works in the sample, right? Uh, Breaking it down a little bit, because this sounds very technical. How can I say that if I offer this product to 20 users, that all of my other 10,000 users will also use this product in the same way? That if my 20 users are purchasing things on the website more, the other 10,000 users will also purchase things on the website more. That is statistical significance, and all experiments aim to be significant in nature. That is, you allocate enough users to an experiment that at the end of the day, when you get data saying, hey, users of group A or variant A, where on the Google Merchandise Store there was this old search with the pop-up and the go button, versus users of variant B, where the search box was here, and as you typed, you can press the enter key to reach the search results page. Um, these Comparing these two methods, which one will be better is my question for an experiment, and how to answer it with data we'll look at in a second. How to answer it with data works with the event infrastructure. That is like ensuring to have funnels here for both groups A and B, and then seeing whether group B has a more statistically significant has a statistically significant funnel which has shown an improvement to me, right? Few examples of experimentation I'll take you towards again. Example one, creating a lack of choice. That is, instead of having a close button on my pop-up, for example, I don't have a close button. And the user, in order to close this pop-up, has to click outside the pop-up, right? This also means that some of the users will think, hey, this pop-up cannot be closed. So to use this website, I need the app. So they click on the app store and they download my app. If downloading the app is my success metric, right? So I remove the pop-ups close button, and this basically tells the user, hey, you cannot get back to the website without having the app, and then the user downloads the app. But this could go heavily wrong as well. There's a second hypothesis which says if you remove the cross button and the user still doesn't want to download the app, the user will just leave your website, right? But we want to see whether these two hypotheses, which one outweighs the other. Out of all both these two hypotheses, which one outweighs the other? Whether more users go to my application or more users exit the website. If more users exit the website, of course, my download rate will go down from my website. And if more users are actually downloading the app than leaving the website, my download rate will go up, right? And then I look at this funnel, a similar kind of a funnel as shown here, maybe a little more complex funnel. And I look at this funnel for both the user groups. That is, the users, I release this experiment, 50% users have the cross button, 50% users don't have it. And then I release it to 50% of users. I wait until I get enough data. And by enough data, I mean that enough users have been on this screen in both the groups. That would make this sample significant for the whole population, right? Sample size calculation, significance calculations, this is a whole different plethora of subjects, which I'm not really going to enter into right now. But of course, you can always Google these buzzwords and read about how it works. I can show you a quick example of sample size calculations online. And then so first sample size calculations. Let's go do this. All of these tests, which are experiments, are either Bayesian in nature or they're like numeric in nature. Bayesian tests mean that you want the user to perform a certain action, maybe download the app more often and something like or something like that. That is a percentage kind of a thing. If you can measure it in percentage, that is 65.9% users are reaching the details page. I can measure this metric in percentage. And if I want to improve this, this would be a Bayesian test. And if I want to improve something like the amount of money that the users spend on my platform, that's a numeric metric. So that would be more in the class of the t-tests and ANOVA and MANOVA and such. And again, these are buzzwords and require a lot of theoretical knowledge. So we'll not discuss these in detail right now, but I will go over a Bayesian sample size quickly. Before doing a test, there are various things we need to do. So I know, first of all, I need to know what success am I expecting from the test. Here in this test, I'm expecting the users to download my application, right? That is my success metric. Second thing I want to know is what are the trade-offs. My trade-off is that the user might not download the app still, and they might just leave the website. So users bouncing away, or the percentage of users bouncing away, is my trade-off metric. And then you could map like you could call the success metric a KPI, a key performance indicator for the experiment, right? And so after mapping my key performance indicator and after mapping my trade-off metric, I want to see whether this trade-off metric uh, doesn't decrease, it doesn't increase as much as my KPI. And if the KPI has more success than the trade-off metric has as a failure, or increase in a trade-off metric if I call a failure, if my success metric is working better, I say, hey, like this test was a success, right? But I want to say that in a statistically significant manner. To say that in a statistically significant manner for the whole population, I need to see how many users need to be in each sample size, in each of these categories of tests, to be able to say that this will work for all of my users, right? To say this, I first need to check baseline conversion rate. Baseline conversion rate simply means how many users are currently downloading my app on the old version. So I could say maybe baseline conversion rate is 5% people download my app. Then I say expected uplift in conversion rate, right? How many people more do I expect, or how much percentage of people more do I expect to download my app, right? I say by removing the X button, earlier, people who were closing this pop-up and going away was 30% people were going away out of the 95% here, which which the 95% inverse baseline conversion rate. That is, out of the 95% who don't download the app, 30% were closing the pop-up and going back to the website and doing something else, right? I say like as a minimum effect, I want to see 5% of these people returning to like not leaving from the pop-up and downloading the app. That is 5% of the 30%, right? 5% of the 30%, 5% of the 30% of my total users, I want, so essentially this 5% I want to convert to 10%. So I say expected conversion increase is 100%. That is, this 5% will be doubled to 10% of my users now downloading my app. This is really ambitious, really ambitious. Usually this is not how it works in practice at companies. You'd hardly be expecting a conversion rate of 10, 15% at maximum in a very good test. But this is just to show you an example. And I say the number of variants in my test because the number of variants would determine the kind of statistical test or significance test that we use for computing a sample size at the back end, right? Like because with two samples, you like for example for a numeric variable with two samples, you'd be using a student's t-test, and for a numeric variable with three samples, you'd be using an ANOVA test. So it really depends on the number of variations in the test. The number of variations also, like, so explaining number of variations means the number of types I am offering of this product, right? An example of more than two variations could be that instead of having just the variations with the pop-up and with the text box here with the enter key, I could have a third variation where a search bar is here, and as soon as I type, the search results start showing. That could be variation 3 in this Google test that I'm planning, right? So the number of variants, and then we we say how many people do we get per day on this screen. So 5% of my total website users come on the screen. Like 5% of my total website users download the app, and I say 60% of my total website users come on the screen, right, per day. So if total users coming on my website are 10,000, then 6,000 is the number of users coming onto the screen per day. And then I calculate the sample size, and then I say you need a sample of 10,000 users, right? And then which will approximately take 1 day, which is basically 2 days, right? Because 6,000 plus 6,000, and that is 12,000 users. But yeah, like, essentially this also heavily depends on your parameters. So if, for example, if the baseline conversion rate was 0.5, you would require a much higher sample. Or for example, the expected uplift was way lesser. It was only 5% if expected uplift, would require a much bigger sample. Still calculating. You will have to run the experiment for over 2 months, for example, here for 5% expected uplift. For 5% and 5%, 85,000 users, right? So as the baseline conversion rate goes down, and as the expected uplift goes down, the number of users I need to get in a test increases, right? So this is why sample size is so important, right? If you check an experiment which requires 10,000 users, if you check the metrics with just 5,000 users in each group, when you release this to the 100% of your market, one of these variants, you might not get the same success that you were expecting from the product later, right? So that is why our sample sizes and statistical significance are really, really important with experimentation. And this is another example. I'm not going to go too much into detail, but I want to sell a product which lets your skin look younger to some people, and on the left side I show a pop-up saying, hey, you get a 10% off on any product of ours. Like, like, so buy now. And there's a buy now button, and on the right side I do a test saying, hey, you have only 15 minutes to avail this discount. Of course, if you create a sense of urgency in the user saying, hey, you have just like 5 minutes to purchase now if you want this 20% off, then of course some of the users will feel obliged to purchase this product if they want it bad enough within these 5 minutes, right? So these are all psychological techniques that they've started using in data analytics. And a huge gap that I see from university learning versus actual practice would be that the university student learns how to calculate these numbers. Like a lot of these numbers that I mentioned before, a university student learns how to calculate all of these, but not how to read all of these in terms of a product, a website, an app, right? And that is why it's becoming increasingly more important for allow for universities to have partnerships with companies with real data, and allowing students to see this real data. All kinds of things like corporate visits, or having mandatory internships with companies. These kind of things promote such real world practice for students. Coming back to the last part of our presentation today, solutions in practice. I've outlined somehow like how using all of these things. Of course, I've spoken about many of these things which we're going to see now in the previous slides as well while talking, but I'm trying to bring it all together here. Like, first thing, the KPI tree. This is the holy grail for any data analyst, any product analyst, any marketing analyst, whatever, right? You've got a goal for the company and you want to see how to reach this goal, right? So a product analyst's job, mm, like the first job is to figure out which actions can you track in a small period of time to predict what the user will do over a course of XYZ months or years or days, whatever, right? So it could be for an e-commerce website. I know that, for example, a user, a user who looks at 10 products on their first day will most likely make a purchase by their seventh day. If I know this, I can say that my job in the beginning of the funnel, that is when the user just has arrived at my website, my job is to show them as many products as possible and to allow them to read details on as many products as possible. Because then I say if this user has viewed 10 products on their first day, they will convert, like they're 20% more likely to make a purchase on my platform. If I know this from my base data, then I can start optimizing for number of products the person views on their first day, right? So I've given two examples here. The first of a ride hailing website, that is a ride hailing website like Uber, Ola, right? Or Rapido and such, right? So if their uh, top goal is the number of completed trips, right? Because completed trips bring in revenue. So what could be leading up to number of completed trips? The two most obvious things would be number of drivers and total hours the drivers work, right? So number of the daily capacity of drivers. This is the most important in my opinion, because if there's no capacity, the trips cannot happen. And then trip requests per day is my second most important thing. Whereas completed trips would be an overall objective of the company. That is, please increase the number of completed trips in this quarter, at the end of this quarter, by 10%. How do I increase it by 10% by the end of this quarter, right? If I don't have data, I would be shooting in the dark. I would be saying, okay, maybe I start offering a 5% discount on the first ride, right? But I cannot make forecasts related to this. Will this 5% discount cost me more than the extra trips that I get, right? This all is made available by the data that we have, like the behavioral data that we have, trip requests per day. So you might be tracking trip requests in a relational database as well. But when we look deeply into trip requests, we can look at where did the user come from? Which kind of user, like let's say the user came from Google, the user came from a Facebook campaign that I was running, the user came from an advertisement that I was running, or the user came from a referral which another user made for bringing this user onto the platform to get a 5% discount on referrals, right? So looking into these things, I can say, okay, which kind of users are actually making more trips, which kind of users are more likely to make their first trip, right? So I say, okay, people who have been referred by other people saying that, hey, this is a really cool ride hailing app, are making more trip requests per day. So I start trying to persuade my users to make more referrals, right? So as you see, making more referrals is not directly relevant to completing trips. But here I have an insight-based infrastructure. I say one thing leads to another, which leads to another. And this is only possible with behavioral data. Similarly, how do I increase capacity? I increase the number of active drivers on the platform and I increase the number of hours a driver is available. Of course, increasing the number of hours a driver is available is a double-edged sword, because I could be putting my customer in an unsafe situation. If I tell the driver, hey, every hour you work above 8 hours, you would get $50 extra per hour. If I say this to a driver, and a driver starts working 14 hours, and on their 15th hour they actually get into an accident because the driver slept while driving, right? That is my trade-off there. So these kind of things are all hypotheses which we can make through our KPI trees, and the lower levels of the KPI trees can be optimized. That is the number of trip requests per day. This thing is what I can mention for which I can measure for yesterday, just today, right? And this leads up to my quarterly trip completion goals. Similarly, for another company, monthly active users could be an objective. And for them, there could be three streams of monthly active users: the new users who come in, users who return, and users who left my application for months and then returned again, reactivated, right? Similarly, new users could have two KPIs which are leading up to new users. That is number of views on App Store and the conversion rate from App Store to the new users, right? And App Store views might have two different breakdowns. That is organic leads that the user had searched for my application and they got my application, or from Google search, or on the Play Store itself, or on Apple iOS Store and such. Verse and paid leads, that is the advertisements that I'm running, right? It could have many other sources, as I mentioned earlier, referrals, and various other things, right? So the KPI tree is something really important for a user. And here it would be one of my sincere requests to, for example, to all the teachers here, to start trying to get this kind of a thinking within their students, within their software engineering students, because having this kind of an understanding allows students to make better applications. It allows them to get more ready for their jobs. And it also because this kind of a KPI tree, even though it is created by a product analyst or a data analyst, right, this is optimized by the whole company, no matter who it is: a software engineer, a product manager, even a customer service executive is going to optimize all for all of these things, right? So it is basically, once this KPI tree is created, this is company wide, and the whole company works towards the low level objectives to, at the end of the quarter, the end of the month, the end of the year, see whether the main objective at the top of the KPI tree has improved or not. Then a second really important solution that we get through this data analysis is the Pareto principle. It is to try to uphold the Pareto principle. Sometimes we see that very small changes can create a very big impact, right? Let's take an example. If I see that 10% of the users on this Google merchandise page, if they're on this page, for example, on the Google Word Cube page or any other product page, details page, 10% of the people who 10% of the people who are like um, 10% of the people who are on this page actually buy the product, right? Or on any product page actually buy the product. If I say, then how can I increase the amount of people who buy the product, but not by doing something hard like implementing a new discount mechanism? That is, implementing a discount mechanism is a hard thing because you need to look at various things like cost of the discount, whether we make unit economics possible at the end of it, whether at the end of the discount we earn enough profits and such. These are a lot of research. A lot of research goes into discounting, for example. Or if we can make it better by or if we cannot make it better, cannot make the detail page better, because for some company like Amazon, there are millions of sellers on the platform, and each seller maintains the description of their product, the like these details of the product and sizes and stuff. What if this information is not available on some product, and I want these details to be added? That's a huge task for Amazon, because they will say, okay, if like if we start getting these details added, it could take months on end with so many sellers, right? So there is a high effort. Of course, the benefit is also high, but the effort is really high. What can I do as a small, low effort thing without to to help convert, to help get more sales at the end of the day, or to help get more purchases at the end of the day? We've already talked about this in the previous few slides. That is this drop off here. You see users reaching from the search results page onto the detail search into the product detail page. There are around 20,000 users or 20,000 odd users, 25,000 users who are not even getting to the details page, right? If I can somehow make more users go on to the product details page and 10% of these users convert, I already have 2,500 more orders. So that is like essentially having quick wins. So here in terms of Google, if I say that coming onto the search screen is what makes the what makes purchasing better, then if I fix the search, it would it would be much easier for me to do than to fix, for example, like than for example to fix something from the search page to the purchase. So you have so it helps you the data helps you see how you can still gain growth on the main metric on your KPI tree without having as much effort as let's say like something else, right? So when we are doing data driven decision making, we compile all the initiatives. We make this huge box of initiatives saying, hey, we can do these 20 different things. In what order do we do these 20 different things is what data would inform. Data would inform we have X percentage of benefit from each of these developments. And then the engineering would inform we have X percentage of effort on all of these details. And then we look at this effort and we look at the benefit. And put, we build initiatives which have the least effort but give us the most benefit first, right? So the Pareto principle says that most of the times, just 20% of the effort can give you 80% of the benefit. And the rest of the 80% of the effort is not required because that gives just 20% of the benefit extra, right? So my job is to work on things which give me the most benefit first, and then pick up things which are high effort but less benefit. And then finding innovative ways to experiment. That is having a high effect size. Effect size we discussed in briefly earlier. Effect size is, in simple words, non-mathematical terms, effect size would be how much benefit does an experiment produce. That is 5%, 10% benefit, 20% benefit when I release this experiment to my whole population. That is all of my users. Then statistical significance. And this is really important because many people would be running experiments across a company in the tech team, and we want to see which kind of experiments actually lead to significant successes, and that we are not taking decisions based on experiments to release a certain version of the product until and unless I see that this version will bring benefit for all of the users and not only things which I see because of statistical noise. Then contributions to company goals. That is, I need to ensure that all of these experiments that I'm planning to do earlier, like these things that I showed you with experimentation, we also need to ensure that all of these experiments are related and will work on one of these low-level KPIs so as to work with my high-level KPI tree. And whether like what kind of market share my experiments or my developments contribute to. This is something also that is the job of a data analyst, because a data analyst would be able to say, okay, you're making changes on the like page on which you have biology content, but like sure, people will sign up more from that page. Yes, 20%, 30% people will more sign up more from that page, but does that really make sense for us? Because I see that only 5% of our total users are using the biology pages, whereas instead, if you invest in English pages, which around 60% of our users visit, you would have a much higher amount of people finally converting to signups. So ensuring that market share that my market itself, that the market that I affect with these changes or with my development, with any software engineering effort, is affecting an appropriate size of users that I need affected. And even if it is affecting a small set of users, at least those users bring in enough business to justify this effort. Okay. Now I will just discuss briefly a few futuristic things that are coming up right now, which we are experimenting with at my company and various other companies. That is, there are low code environments is the first thing. Low code environments are environments like this, like Google Analytics. This is a low code environment. It doesn't require any coding from my side. Just the only coding part that this Google Analytics requires is the developer to add JavaScript on all of the actions that I need to track. And then I get all of my data mostly. If I want to build custom reports, I can do that with a drag and drop and select kind of a feature. I can select my dates here and stuff. I don't need to do SQL and Python analysis, right? So low code environments are any environments which allow you to do analysis or engineering or any such thing. Low code environments is also a buzzword in software engineering these days, right? So environments which allow you to, for example, Java NetBeans or like Visual Studio, which allow you to use drag and drop components for doing a lot of your code, right? Because for example, Java NetBeans, you wouldn't really be making most of the GUI elements, right? You'd be dragging and dropping most of the GUI elements. Similarly, for data analytics, products such as Google Analytics, Amplitude, and such are all low code environments. And these days, because data analysts are expected to know more about how to read data, that is, after looking at these numbers, can I draw some insights and help the company get more benefit than to spend my time cleaning data at 20 different places and to spend my time writing Python code for like 10 hours a day. Instead of doing that, can I spend my time in a more beneficial manner? Can I spend my time creating experiments and solutions and research for the company instead? So that's why low code environments are popular right now. This is not really a futuristic thing. This is futuristic for students. Like students currently need to learn a lot more about low code environments in terms of data analytics. However, it's sort of like very standard with companies these days. Then AI generated code and insights. This is coming up with like various things, like the data spell has a mechanism in which you can ask it to write code functions for you. It is write a function to clean this data set of null values, write a function to clean this data to add average values to each empty value in this column. It can write all of these functions for you, like with like one prompt. Similarly, AI generated insights could be available with, like, for example, a tool like Amplitude. Amplitude has like an AI assistant wherein you have all your data on Amplitude and you can ask this AI assistant questions about your data, like what percentage of my users are getting to the purchase screen or the cart screen after looking at 5 products. You can ask it these kind of questions and it would prepare like a nice, beautiful graph for you. Data as a manager. This is something which is very new for traditional companies and huge companies. That is, even company bonuses, team bonuses these days, and everything is decided on data. Like that is all this KPI tree that I showed you. If this top of the KPI tree is better after a certain time period, I would give my company a bonus. I would give the engineering team double bonus if it's like higher than my expected target and stuff, right? So this is also data driven these days. That is, your bonus does not depend like not only bonuses but also the success of a company, right? Whether you say that the top management's decisions were right or wrong is also told by data these days. Or for a startup, in the startup world, whether you get the next round of funding or not would be told by data these days. And automated reporting is also coming up. That is like you develop uh, like code files, Python files, and such, which basically send you automated emails all across the week or every month with like your whole rundown of what happened last week or last month, and comparing this data to whatever you need, right? So you do this analysis once, and then it can be viewed multiple times, viewed by many people. It complete refreshes on its own and such. So automation is like a huge thing in data these days, because data analysts increasingly want to spend lesser and lesser time on coding and data preparation, and more time on generating insights for the company to improve their business. And here are the references I was talking about. All of the images and some of the information for my presentation are from these websites. And amplitude.com is what I mentioned earlier as well. This is the a self-serve data product. You can always go and read up on how they're doing this to understand event store data better. And of course, you can definitely have a look at some of their latest visualizations and such. You can get a demo account for free if you're a student or a teacher. Universities can get demo accounts for free. So yeah. And then um, one more thing which is very relevant for teachers is that Google Analytics actually has a demo account. The thing that I'm showing here is actually real world data of real world users who are using the Google Merchandise Store, the my example which continued the whole time, right? And I have also the link to the Google Analytics data of the Google Merchandise Store, and I will post this in the chat here. And I request Dr. Aurelia to post this on YouTube for everybody. Okay, I'll post this at the end of my presentation then, because it's like I cannot get to the chat right now. Okay, cool. And finally, coming to questions. Any questions that you have? Okay, I found the chat. I'm posting the link now, and you can, yeah.
Thank you so much, Sarthak.
Thanks a
That
lot.
was indeed a very wonderful, session. Our
Thank you,
WhatsApp
ma'am.
group as well as our YouTube chats are flooded with lots of comments and satisfaction with related to your session. That was indeed a great session. Thank you so much. By the way, I
Thanks a
have
lot to all of the audience.
yeah,
Sorry.
thank you so much. I have posted the questions which I have received from the YouTube as well as WhatsApp group in our Zoom chat box. Would you mind going through it and responding
Yes,
to that as well? Thank you.
sounds great. Okay, so let's please give some event-driven databases as mentioned. You can already look at Google Analytics, the link of which I posted down here. And Dr. Aurelia will also post it in the chat box there. Google Analytics is one of the most basic data event-driven infrastructure systems for any marketing or product analytics these days. It is implemented by almost every company. Like every startup that you see starts with Google Analytics because it's cheap and it's really well available. A second example could be Amplitude. It's Amplitude. Amplitude is one of the more commercial event based infrastructure systems, and this is used by more product analysts than marketing analysts. But Google Analytics is more universal; it's used by almost everybody. Then this is something which I wanted to mention earlier as well, but I forgot. So nice question, whoever gave it. Um, MongoDB. If you teach MongoDB at a university, this system was built for such data. This system was because as you see documents, right, like as you can imagine, if you're tracking stuff like clicks and scrolls, you'd be generating millions and millions of rows of data if you have only 100,000 users. Even with every usage of a user, you'd be generating like 200, 300, 400 events. So many companies implement Hadoop Hive infrastructure based on Postgres or MongoDB to have event-based data as well. If you want to build it from scratch, then these MongoDB, PostgreSQL, Amazon AWS Redshift, these are some services which are used. Whereas if you want to have a self-service tool, the other tools that I mentioned, Amplitude, Mixpanel, Google Analytics, and such. Which company can I use that can do such research and tell me such analyses for my website? There are various marketing companies which you can contact, and you can always search for data analytics service companies. But this question is not very well related to the topic at hand, and which is why I will skip going into detail here. But basically, companies like TCS, Infosys, everybody does data analytics and such kind of research for people's websites as well. How will you know optimization is achieved in data analytics? Optimization has various aspects for me. I don't understand which kind of optimization you're talking about. I will touch upon a few topics here of optimization. First optimization could be whether you whether or not you're collecting data which is which is relevant to you, because event-based databases can get really heavy, and if you have somewhere around more than 50,000 users, you can already think that you're generating data in GBs every day. If you're generating data in GBs every day, you would only want to track what is important to you. So as I mentioned the KPI tree earlier, usually what companies do to save cost on data and optimize on these event-based data stores is that they only track whatever is relevant to their KPIs. The only actions that they track would be relevant to their KPIs or relevant to their research in some way. But anything else which is non-relevant, don't track. For example, if your website has a very small scroll wheel, if it's going to scroll only like one page more, then why implement tracking for scrolling? It's just generating useless events when you know that there's not much to scroll, right? So that is one optimization, that is saving cost on data. Second optimization, using data, like all other optimizations are like based on solutions which the insights provide, like like that is product optimizations, like I talked about. So when you experiment, you see certain things work, certain things don't work. When you implement changes, you see that certain things make your key metrics better and certain things make them worse. And of course, these optimizations then just mean whatever works, you stick to it, and whatever doesn't work, you remove it from the tool, from the product. What will be the duration of the sample calculation? The duration which we saw on the calculator, it means how long will you take to get these insights, get this data in a statistically significant manner. You see this 2 weeks here. This 2 weeks essentially means that you will require, because you have 6,000 users a day and you need 85,000, you will take 2 weeks to get these 85,000 users on approximate levels. But when we start doing A/B experimentation in the real world or for companies, we also come across certain times when you require like just 2 days to get your sample size or 3 days to get your sample size. But we say, what about seasonality? Because seasonality is a basic principle of data science, which I did not really touch on right now, because this is a very basic thing which all universities, all data analytics, and all computer science teachers know about. That is, for example, on weekdays, you might be getting a different user behavior. On weekends, you might be getting a different user behavior. For example, Amazon on Tuesday, Wednesday, Thursday might be getting lesser purchases, whereas on Saturday, Sunday, when people are more free, might be getting more purchases, right? Because seasonality exists, usually we recommend that any experiment is run over a course of at least 1 week, so that we at least capture the weekly seasonality in our data. Then let's look at, can you justify from USSR perspective? I'm not sure what you mean by USSR perspective. What kind of databases are typically used for storing event-driven data? I've already answered this. How and why to use the KPI tree? A KPI tree is a non-negotiable for any company. If you want to make data-driven decisions, a KPI tree is required because you would have some company goals, and a KPI tree connects company goals to data analytics. Until and unless your company goals are connected to data analytics, even if you're doing data analytics and making solutions based on data analytics, and this is not contributing to the top level goals of your company in some way, this is useless. So if you're doing data driven decision making, a KPI tree is really important. How to create this type of key? I'm not sure about what type of key is being referred to, so I'll skip this one. How about distance traveled? Also don't know what this question is about. For the KPI tree, so the question that I'm reading right now is, what is the role of the KPI tree and how to create it? Is there any practical approach? No, a KPI tree is practical. This KPI tree is usually just a diagram. This KPI tree just says, hey, like, like we want to optimize for example, number of purchases for an e-commerce website. At the end of the day, they want to work on the number of purchases. Then you start thinking logically. What leads to the number of purchases? First thing, number of visitors on my website. Second thing, number of visitors on the detail page. Third thing, maybe something like number of visitors adding products to their cart, right? These are the three things off the top of my head, which would lead to users purchasing products more or more often, right? So I add this to my KPI tree, and then I think, okay, users reaching the cart page. What is, like, an even lower level action to this? So users adding products to the cart would be dependent on users, like users viewing the product details page, right? Users knowing more about the product and seeing that this is the product that they require. The price of this product is also what they are ready to pay. Then only they will add it to the cart. So price that they would the users reaching the detail page is actually leading up to the percentage of you like the users adding to cart, for example. Similarly, users reaching the product page depends on the number of users I get per week on my platform. So the amount of users I acquire per week or the amount of users who come to my website per week are actually leading up to users reaching the product page. So this is how logically we connect KPIs to each other. And then I would try to optimize the bottom of the KPI tree to optimize KPIs which are higher at the KPI tree. KPI, okay. Then the next question is explanation about KPI in detail. KPI simply means key performance indicator. It stands for key performance indicator. Let's break this down. Key in this term, in this respect, in this key performance indicator means that it is important for me. Key to something. The key to unlocking my business, right? That is the key in this. Performance is whether my business is performing well, bad, not. Indicator. Indicator means it is. So this KPI is a number which indicates how my business is performing, right? There are some KPIs which are top level KPIs in the KPI tree. Top level KPIs mean these are to be achieved at a company level. Then there are low level KPIs. Low level KPIs are more like stuff users do on the platform and stuff and such, or like direct things which we can affect. Users we get from advertisements, users we get from referrals, the like nudging the user with a discount. These are optimizing low level performance indicators, that is users reaching the product detail page, for example, or users reaching the search page, for example, in the Google merchandise store, right? So key performance indicator could be in and it is just a number which tells you how your business is performing or how your product is performing. And key performance indicators are also used in personal terms. How am I performing? Like every like a few months, I have a meeting with like top management, and they say, okay, your analysis have produced this percentage of benefit for us, and that is my key performance indicator. Next year, I want this to be higher, right? These kind of things are key performance indicators. So key performance, don't get scared of the name. Key performance indicator is simply a data analytics metric, and any metric which is important for us is a key performance indicator. How optimization and efficiency is achieved? This could be various ways, like like so. Again, like some efficiency management is done, like for example, sales, like using data that I've got from my previous customers, right? And using data which I've got from previous companies that I've onboarded onto my B2B SaaS product, for example. I can see which kind of companies are more likely to onboard on my platform and which kind of companies are more likely to purchase my product through data analytics. Similarly, as I explained in these previous analytics techniques part, I can also analyze this data. What kind of companies are more interested in my product? What kind of companies use my product more and stuff? And then I can develop a model, for example, and more like not even an ML model, but a simple decision sciences model, for example. That is, if a company has revenue above XYZ number, if a company belongs to the fintech environment, if or the education environment, or if the company has more than 100 employees, then they should be contacted first from sales. So that is how I make the time of sales more efficient. Again, this is all done using the Pareto principle. That is, I want sales to take 20% of the effort and give me 80% of the benefit. In terms of product analytics, this is done in terms of 20% of the effort from engineering to get 80% of the benefit on the main company KPIs, right? So this kind of a thing. How to perform the analytics if I am not an owner of the platform? It is to keep the context of my research work. If you're not the owner of your platform, then probably performing analysis or getting data from this platform is called hacking, and like that is illegal. So please don't do that. Is a KPI tree dynamic? Yes, this is a very good question. A KPI tree, of course, is dynamic. A KPI tree changes as your company's goals change. As a startup, what I want is having some people using my product. So I maintain a KPI tree which is based on my user base. Then, as a second, as I grow much more, right? I want now. I have already users. I have 100,000 users. Now my goal has changed. Now I want my users to use my product more. That is, on average, earlier, if users only used my product for one day and then dropped off, and only a few users came back the next day, maybe retention is my goal at the top of the KPI tree, to make users come back more often and for longer, to stay on my platform onboarded for longer, right? So um, this essentially like is like this essentially is very dynamic, and as the priorities of the product and the company changes, your KPI tree would change as well. And as you introduce new features which are leading up to the top level KPIs, the bottom level KPIs of these new features would also keep being added to the bottom of the KPI tree, because they're producing a benefit in the at the top level, for example. What type of data analytical tools are used for these analyses? Again, quite a few. Like, so of course we use SQL and Python and R whenever we require for some deep dive analyses on this data. And this data is stored just like a database. You can also use SQL on this. Um, and like just like a relational database rather, and you can also use SQL on this, for example, using a Hive Hadoop infrastructure. And then like so that is deep dive analysis. That's on one side. You can use various coding languages for this. There's no limit to that. But for marketing analyses, some big names in the market for tools would be Google Analytics, which is also free to use for all people in education, by the way. So it's very powerful tool, Google Analytics. And then a second very popular tool that I've worked with in the past is Mixpanel for marketing analytics. That is working with paid marketing analytics, social media marketing analytics, or checking just all your outlinks and inlinks and such, these kind of things. And for product analytics, companies use a plethora of products as well, but the biggest ones I've seen being used in the market as self-service SaaS tools are Amplitude and Mode Analytics. I've already mentioned the advantages of KPI tree before, so I've answered with the previous question. And then, is there any data set used here? Yes, of course, I've used the Google Merchandise Platform dataset at some places, of course, which is freely available by Google for everybody to use, the link that I shared earlier. So I used some analyses from there to see what examples I could give you. Like I looked at search data of the Google Analytics store, Google store, and then this search data showed me that there is like this really outdated search mechanism here, and that is why users are dropping off from the search and stuff, and they don't want to use search. So that's why I gave this example in my presentation as well. And essentially, like all of the other data is open source data sets available from various places, and some of the data has not been analyzed by me. The pictures that you saw earlier, some of this data is also from the reference links that I provided you. Some people have done analyses, there are some white papers there and such, and I've used analyses from there. Sir, can ChatGPT provide data analytics on web pages which we require? ChatGPT can provide analysis, but you would have to provided very huge data sets, and it has a limit of 2,000 tokens. That is 2,000 words. So that would not be possible to give it like million rows of data and such. But there is the GitHub Copilot, which is a very cool tool. You can explore this. Maybe it's also available for educational users for free. And GitHub Copilot helps you write code and for analysis and such using an AI tool just like ChatGPT. So that's like there's like a whole class of different products, right? There's also if you've heard of the library Pandas for analyzing stuff on Python, then Pandas has a new AI platform. Has a new AI inbuilt in this in their Python module, which is called Pandas AI. So if you add CSV data to Python using Pandas and you use the Pandas AI functions, you can basically analyze this data using Python, using Pandas, and you can tell it, hey, create a summary of so data and stuff, and it'll create like a summary table. It'll add some insights with all percentages and stuff, calculations you require, everything it'll do for you. Which type of decision is more successful in the future? I don't understand in which respect do you mean decisions? How do you navigate decision making in the absence of quantitative data? So decision making in the absence of quantitative data is of course taken using qualitative data. And qualitative, like for example, for companies who are starting out new, they do competitor analysis. They look at various competitor products, see what they're doing, see what kind of blog posts they do, and various other things. And this helps them get a starting point. They do also market analysis. That is, they look at how users have worked with certain products in the past. There are many companies who do this. G3, for example, is a big company, big name in this space, and they provide qualitative data. Then you could do this using surveys, or just literally go, like, I mean, take your product, go out on the street and talk to 20 people. You would get quantitative as well as qualitative data this way. um, and basic, I've seen this happen so many times. Like I was in a company where there were only 10 people working, and we used to have 30 minutes every afternoon for talking to our users. So we used to go out, down, and like outside the office, talk to just people going on the street and such, and figure out how I can, like figure out what they feel about our product, and what we can do next and such, because we didn't have quantitative data, because we didn't have so many product people actually using the app at that point of time. And third and final source, there are many community data sets of real world data which are available. Many companies release their own data sets after removing PII and such, and many research companies also give out data sets. Also, the commerce chambers of India and the census department of India, I forgot what they're called, the statistics agency of India, they also release a lot of data sets regarding economics, regarding certain usage trends and stuff. And it's always really interesting to read these research papers. Um, how to merge two different data sets? This is a question for Google. How data analytics helps in SEO? Analytics helps in SEO because you can always you can always see on Google Search Console about how your what kind of keywords are being targeted, and what percentage of users use a certain keyword to get to your website and stuff. Now this is a whole different class of data analytics, but called marketing analytics. But this basically, this data helps inform you what kind of keywords to mention again and again on the website, so that they show up more in search results and such. And also your outlink and inlink analysis on in, like for example, Google Analytics, like which links are users using to come to your website, and which links are users using to leave your website, can really help in SEO analysis to put in the correct links at the correct places and such. Can Hadoop tool is recommended for such analysis? Yes, Hadoop databases are built for such kind of really heavy distributed databases, and for multinational companies where data is being generated in various countries and various servers, and to bring this data virtually into one database. Can you suggest any free course available in data science? There are various on Udemy and Coursera. Just pick any and go with it. Most of them offer all the same kind of basics. After you have done with the basic course, then I would recommend Coursera courses offered by universities only for advanced courses, because basics are all the same for every data analyst. Which software tool more helpful in today's technology? I think if you're starting out to learn data analytics, just go with SQL. That is your best friend. Which one is the best platform to learn this? User-friendly app is available. Google Analytics has free courses by Google on Google Skills Academy, and you can go on Google Skills Academy and search for courses for Google Analytics, and you can learn about this event structure, infrastructure, and a lot of other things on Google Analytics. They would also have specialized courses like the product analyst course and stuff, which you can learn. Again, most of them are available for free, which is why you don't even need to pay a penny. And they also offer a certificate at the bottom, which you can at the end, which you can put on a resume. Do KPI relate with the employee retention, also with the salaries? We're not talking about employee retention here, we're talking about customer retention. And also, yes, for employee retention also there are KPIs, which is another field of data called HR analytics. You can read more about this if you want. How to perform the analytics if I'm not an owner of the platform? You cannot. You need the data. You need data access from the database. Data analytics analyze on what kind of data? Data analysis can be done on any data. It just needs data. I explained the futuristic goals of this data because this was a faculty development program meant for teachers in different universities and such, or professors in different universities. And as such, my focus was not on basic data analysis, which I'm sure that all of you teachers know about very well already. I'm talking more about the advanced stuff which companies use these days. So data analytics can happen on even relational data, on any kind of data that you have, like essentially as a basic. And that's all the questions I see. So thanks a lot, everybody, for tuning in. And it was a great session, I would say, for me to be getting this opportunity from Christ University. I again thank Dr. Father VC and Dr. Ashok Emmanuel for giving me this opportunity, and Dr. Sagya Aurelia and Dr. Smita Vinod for organizing this. And of course, my alma mater, Christ University, for always giving me the best opportunities possible and for trusting in my skill. Thanks a lot.
Thank you so much, Sarthak, for that wonderful session, and maximum questions we have addressed. In case if we have missed few of the question, we'll address shortly that as well. So it was indeed a great session. People have responded that it was an excellent, informative session. We are happy. Few from non-computer science background also, they have got an interest to get into data analysis, and they felt they were very engaged. So on behalf of the Department of Computer Science, Christ deemed to be university, I take this honor to see our own student flourishing and being in a position to orient all the faculty member. We are very honored to have you. Thank you so much. And we also thank all the participants for their patient listening towards the session, and the feedback link is posted in YouTube chat. You can fill the form for all further certification part of FDP as well. So tomorrow we are not having any session. We will resume our day 2 FDP on Monday, same time at 6 o'clock. Thank you very much. Have a nice day. Weekend as well.
Thanks a lot, ma'am.
Thank you, Sarthak.
One question. Sorry, I forgot. If anybody would like more information, you can always visit me on LinkedIn. I'm just gonna put in my LinkedIn here, and you can always just like follow me or like text me on LinkedIn if you have any questions or would require any further support on information that you got today. And
Thank
thanks
you.
everyone for the kind words.